Tuition Mobile, quality e-learning experience on the go.
You're welcome back to the class. We'll be talking of Matrices, part 2, dealing with Matrix 6, 2. Alright, and here we'll be talking of determinants of a matrix, the cofactors of a matrix, and the adjoint, the inverse, and the rest. Here we'll be using examples to make these explanations on matrices. Okay, and we just used one example, and that is why it is good for you to pay particular attention. For determinants of a matrix, okay, for determinant of a matrix, in order to determine the determinant, matrices will be arranged in the following form. In the range starting from positive, negative, positive, negative, and then it continues. Okay, and then the next column starts from negative, positive, negative, positive, and then it continues. And then the next column starts from positive, negative, it keeps alternating, and then it continues. That way you have the next column start with negative, positive, negative, positive, and then the arrangement follows that order no matter how much the columns are. Alright, so we'll be using a particular example. Okay, example 1, we'll be using it to go through all the topics we'll be talking about. Like we said, we'll be talking about determinants, cofactors. Okay, we're talking of inverse of a matrix, and then we're talking of adjoint of a matrix. Alright, and so for the determinant, if we are given a matrix A equal to 3, 2, 5, 4, 7, 9, 1, 8, and 6. Alright, so how do we find the determinant? Alright, look at the way we find our determinant here. We find the determinant by keeping some parts of the matrix constant and multiplying some other parts, keeping some parts of the matrix constant. Alright, and then we are given this matrix to take the transpose to get the determinant. Rather, determinants are symbolized with this form, or you can say determinant A. Okay, so we have to get the determinant. Determinant of A is equal to, now look at the role of the symbols here is positive, negative, and positive. And for determinants, we are only interested on the leading row, on the leading column volumes. And so when we keep the first column constant, it's like we are covering the first column, and then covering the first row we have values like 7, 9, 8, and 6 out. And so you have 7 times 6, alright, minus 8 times 9. Okay, all in the bracket of the leading column number, which is 3. Fine. And then the next value that follows, if we cover the second row, okay, and the first row, we'll be having values like 4, 9, 1, 6, 3. Okay, good. And the leading number on the column is 2, and it's not just 2, it's minus 2 because of the minus on top here. So we have minus 2, the leading column number for the second column, and then we have 4 times 6 minus 1 times 9. Alright, and then for the next column, if we cover this, we will have numbers like 4, 7, 1, and 8, 3, and so we multiply them, and the leading column number there is plus 5, plus 5. Okay, and then we have 4 times 8 minus 7 times 1. Okay, and so this follows that we have 3, 7 times 6 is 42, and 8 times 9 is 72 too. Alright, minus 2 into 4 times 6 is 24. 1 times 9 is 9, and then plus 5. 4 times 8 is 32. 7 times 1 is 7. So we have 3, and 42 minus 72 is minus 30, and 2 into 24 minus 9, which is 15, and then we have 5. 32 minus 7, and we have 25. All right. Okay, so on the next column we have 3 times 30, that is minus 3 times 30, and then we have 90. That will be on the next slide. Determinant of A is equal to 30. Sorry, minus 3 times this is 90, minus 30 is minus 90. Okay, and then minus 2 times 15 is minus 30, and then 5 times 25 is equal to 125 plus 125. Okay, so we have the determinant of A is equal to minus 90 minus 30 gives minus 120 plus 125, and so adding the two numbers together we have 5. So therefore the determinant of A is equal to 5. Alright, and so this is how we obtain our determinant. Okay, so the next thing we'll be talking about is cofactors. Okay, cofactors are obtained the same way you obtain your determinant. Okay, but there is a different method for that. Alright, for cofactors, each element in a matrix will give rise to a cofactor. Okay, and the cofactors are obtained by holding elements in the matrix line constants. Okay, and then we will now multiply numbers that multiply and subtract the rest of the outcomes of the matrix. Okay, don't worry, you will understand this by the time I carry out the illustration. We have 3 to 5. We use the same matrix A. We find the cofactor of matrix A. Find cofactor of matrix A. Matrix A. Okay, and matrix A is given to be equal to 2, 3, 5. Is that 3, 5, and 3 to 5, 4, 7, 9, 1, 8, 6, which is equal to 3 to 5, 4, 7, 9, 1, 8, and 6. Alright, I will show you how the cofactors are obtained. Alright, to obtain the cofactors of A, alright, cofactors are written in short form as C of A. Okay, C of A will be equal to, look at the way we go. I think this would have been better on the next slide. Okay, let me use a full slide for this. A equal to 3 to 5, 3 to 5, 4, 7, 9, and the 1, 8, 6. Okay, so cofactor of A will be equal to, look at the way we go. We go into the matrix, keep the first row and the first column constant, then we have the cofactors as 7 times 6 minus 8 times 9. Okay, fine, and then we go on to the second row. We'll keep the second column constant, and the first row we have cofactors like we have 4, and we have 4 times 6, and minus 9 times 1. Okay, I hope you're not wondering how this happened. Okay, what we just did was, just like we cancelled the first row, then we had the first row and the first column constant, we had these numbers. Okay, we had 7, 9, 8, 6 for the first, so we had to multiply 7 times 6 and then 8 times 9. Okay, and then if we keep this row constant, the second row, the second column constant and the first row constant, we'll have 4, 9, 1 and 6. Don't just mind these lines. Okay, we'll have 4, 9, 1, 6, and if we keep the third column constant and the first row constant, we will have 4, 7, 1 and 8. Okay, and so this will give us 4 times 8, and then 1 times 7 minus 1 times 7. Alright, and so we go over to the second row. If you keep the second row constant and the first row, we will have values like this is for the first row. I want to do for the second row separate, and then for the second row, if you keep the first column constant and the second row constant, you will have 3 and 1 left. Is that no? We'll have 2, sorry, and 8, and then we will have 5 and 6. Okay, so that on the second row we can say this is 2 times 6 minus 5 times 8. Okay, and then on that same second row, if we keep the second column constant and the second row constant, we have 3, 1 and we have 5, 6. Okay, and this is as good as saying 3 times 6 minus 5 times 1. Okay, and then on that same second row we can keep the third row, the third column constant, and we have 3, 2, 1 and 8. I want to believe that you've understood how we've been doing this, and then I'm going to be a bit faster and I'm not going to talk much on this. Then I go over to the third row, and then keeping the first 2 row and column constant, I have 2, 6, and I have I have 2, 9 and minus 7, 5. Okay, and then keeping the second row constant and the second column constant, sorry, the third row constant and the second column, I have 3, 9 and 4, 5. Okay, for the last one I have 3, 7 and 4, 2. Alright, these are computations I have to carry out. The cofactor of A is given as 7 times 6 is 42 minus 8 times 9. 8 times 9 is 72. Okay, and this is 4 times 6 to be equal to 24 minus 9. This is 32 minus 7, and this is 12 minus 40, and this is 18 minus 5, and this is 24 minus 2, and here we have what is this? That's if we keep this constant, we have 2 times 9, here is 18, this is 2, and minus 35, and then here we have 3 times 9, we have right, we have 3 times 9 as 27, and 4 times 5 as 20, and then 3 times 7 is 21, 4 times 2 is 8. Okay, so to find these cofactors, we carry out these simple subtractions and addition. Here we have 42 minus 72 is equal to 30 minus, and then 24 minus 9 is equal to 15 minus, and then 32 minus 7 is equal to 25, and 12 minus 40 is equal to minus is that 40? 5 times 8 is 40. Okay, that's 40. Okay, that's minus 28, and here we have minus 13, and here we have 22, and here we have let's see, minus 35. Okay, which gives us minus 17, and then here we have 7, and here we have 21 minus 8, which is 13. Alright, the computation doesn't end here. It doesn't end here. All you have to do is just remember that matrix starts from positive, negative, positive, negative, positive, the negative, sorry, and this is positive, negative, positive. So these signs will be multiplying each of the cofactors. Minus 30 times plus is minus 30, minus 30, and then minus 15. So we have determinant A equal to bracket of matrix 30 minus 15, 25 minus, and then minus 28 minus 13, 22, okay, minus 17, then 7 minus, and 13. Alright, so multiplying the signs above each element, we have minus 13 times plus is 30, minus 15, this changes this 15 to positive, this is 25, this changes this to positive, this is minus 13, and then this is minus 22, and so this changes this, it remains to 17, and then this changes this to negative, and so we have 13 too. Alright, so therefore the cofactors of a cofactor, rather not determinant, a cofactor is equal to minus 30, 15, 25, 28, minus 13, minus 22, minus 17, minus 7, minus 13. Okay, so this is what we call the cofactor of A. Okay, so the next thing we'll be talking about is the adjoint of a matrix. The adjoint of a matrix. The adjoint of a matrix. The adjoint of a matrix is defined as the transpose of its cofactors. Okay, the transpose of its cofactors. Okay, so if you are given a matrix and you are told to find the adjoint, you pass through the following steps. Number one, you find the cofactors of the matrix. Okay, and then number two, you transpose the matrix. Alright, but since we have the cofactors of this matrix, if we want to find the transpose of this matrix, okay, we will just have to transpose these cofactors. Alright, all we are saying here is that adjoint is equal to cofactor of A transpose. Okay, so we have that cofactors of A are equal to minus 30, 15, 25. Alright, and then taking the transpose, we'll have transposing the cofactor, right, and then we have to be equal to transpose of the cofactors, which is equal to transposing C, and if we want to transpose C, the column switches to the rows, and then the second column switches to the second row. Okay, and then the third column switches and become the third row. Okay, so this is the adjoint of A. Okay, this is adjoint of A. Alright, and we'll be talking about inverse of a matrix, and that will be the point where we'll end this class for today. The inverse of a matrix is obtained. Okay, let me first write the topic. The inverse of a matrix. Inverse of a matrix. The inverse of a matrix is obtained by dividing each of its adjoints by the determinant of the matrix. Okay, we have the adjoint of matrix A, for instance, divided by the determinant of matrix A. All right. Formally, this matrix, we are given this matrix to be equal to matrix 3, 2, 5, 4, 7, 9, and then we determined the determinant to be equal to A. So the inverse of the matrix is defined in this manner, and inverse of a matrix is denoted as, the matrix raised to the power 1, just like we have A raised to the power 1. So we have determined the determinant of A, okay, to be equal to 5, and so we'll go ahead to determine the inverse. All right, the inverse is equal to the determinant over the cofactor. Therefore, inverse of A, which is equal to the adjoint of A all over the determinant of A, okay, will be equal to the adjoint of A is minus 30, 15, 25, minus 30, 15, 25, okay, and 28 minus 13 minus 22, 28 minus 13 minus 22, and then the last row is minus 17, minus 17, minus 17, and 13. Alright, okay, so this means the adjoint of A divided by the determinant of A. Determinant of A is 5. Okay, and so this is as good as saying 1 over 5 dividing all the outcomes, the elements in the adjoint, minus 17, minus 13, and so this is as good as saying minus 30 over 5, 28 over 5, minus 17 over 5, 15 over 5, minus 13 over 5, and then minus 17 over 5, and then we have 25 over 5, minus 22 over 5, and then 13 over 5. Okay, so for those that can be divided simply, minus 30 over 5 gives minus 6, and then this becomes 28 over 5, and then this becomes minus 17 over 5, minus 15 over 5, 15 over 5 gives 3, minus 17 over 5, minus 17 over 5, and then this gives 5, minus 22 over 5, and then 13 over 5. And so therefore this is the inverse of this matrix. And so whenever you're told to find the inverse of a matrix, you have to take more than 4 steps. First, you determine the determinant of the matrix. Okay, number 1, you find the determinant of the matrix. Okay, all right. Number 2, you find the cofactors of the matrix, and then number 3, you find the adjoint of a matrix, and then the 4th step is to take the adjoint, the inverse of the matrix. Okay, this is all the steps that leads to inverse of a matrix. You cannot skip any of the steps, you must follow it step by step. But if you are just told to find the determinant, well, you can use from our previous lessons, cofactors, the same thing, but inverse, you must take the 3 steps to get to find the inverse. Thank you for being part of the class, and with this we've come to the end of our class on matrix. Study well and prepare yourself. Thank you.